Okay, guys, so welcome to today's Intellipaat live webinar on platforms design of real-time stock market trading. Today's webinar is conducted by Mr. Ayush Kubba, who is a senior AI and data science professional with strong business acumen and with 8 to 9 years of technical expertise. He has more than 8 years of experience in the field of data science, ML, AI, and related fields. So, guys, let's welcome Mr. Ayush to the session. Sir, over to you.
Thanks a lot. Good afternoon, everyone. So let's start with it without, wasting much time. So we'll quickly talk a bit about me, what I do and what kind of background I have. And then from there on, we will move to the stock price prediction hands-on. Okay. We'll go through some basics of time series so that you understand what is time series, right? We'll jump on, then we'll pick some data sets, right? We'll pick some Indian stock data sets like Tata, Infosys, or maybe TCS, and then we'll try to work on those data sets and try to make predictions. Okay. So code wise, it might be a bit heavy for some, right? But don't worry, right? I mean, that's totally fine and that's totally understood. So, hi everyone, my name is Ayush Kuba. I have around 9 years, close to 9 years of experience working in data science. I actually started my career as an Android developer. I worked as an Android developer for around 6 months, right? And then I got an opportunity to work in data analysis. Back then, I was not happy, right? Because uh, it was a new field, and I came from a engineering background. I never really liked working with the data till that particular time. But that was the only offer that I had, and that was one of the best decisions, luckily or unluckily, I took, right? And from there, once I started working in data analysis, I actually, initially I was working a lot on SQL, and then back then there was a tool called SAS, which is still used for data science also, right? So I got exposure to SQL and SAS. SQL I already knew back then, but then that's how my journey started. Since then, I have been working in this particular field. I have co-founded a couple of startups. One was Curve Analytics, which uh, sadly didn't work out very well. And soon after, I joined another startup called Voicen.ai and led all the AI developments out there. And after around 2.5 years, we were successfully acquired by a company named Sprinkler. Apart from that, I have published some research paper also, and currently I am director of data science at Sprinkler. At Sprinkler, we are working in a conversational AI. Basically, we work on speech to text, text to speech, voice bot, chat bots, right? So for example, we work on basically end-to-end solutions. So let's say you want to contact Amazon. Let's say you bought a product and you're not happy, right? So maybe you made a tweet to Amazon, right? So that whole tweet and analyzing the sentiment of the tweet, analyzing that issues in the tweet is done by, Sprinkler, is done by our AI that's in place. Even if you do a WhatsApp to, let's say, HDFC Bank or, any other matter for that sake, right? So voice, text, or any other channel, mails, right? We provide a one solution which caters to all of these buckets, right? So that's how my main solution or main work has been. The main intention and the main thing to draw from this session will be working on any kind of time series data. Okay. So we'll get to know, we'll learn some basics and then we'll jump to the actual data sets, right? So that's how it will work. Before we begin and try to understand what is stock market, let's try to understand what is stock market. What does the first thing comes to your mind when you hear about stock market? For a lot of you, it will be something like this. So going back here, right? I know. So stock market is a place where shares of public listed companies are you know listed, and a lot of people, right, got to know about stock market, right? And it was a household discussion after one of the series got popular, right? So we'll try to see, right? Maybe we can, like Harshad Mehta, we can also build some prediction algorithm, right? So yeah. So what is stock market? Stock market is a place where you can buy and sell shares, right? Stocks, along with stocks market, there is different other things also associated with it. There are indexes, there is multiple of other things that we can buy and share. Okay, it's not just the stock. right? We can put our money on indexes, we can put money on ETFs, right? A lot of those things are there. And I am sure a lot of people are having their charts in red these days because of the market scenario these days. Yeah. Okay. So stock market, I mean, there's humongous advantages of stock market, right? We companies can raise capital and investors can actually generate personal wealth, and we can be part of big companies, right? Without even working for those companies, we can be a part of those businesses, right? Where we think, if we invest 100 rupees maybe today, we'll get to we'll get some benefit out of it, right? And also stock market, and not even Indian stock market, globally any stock market, gives us some indicator of the state of the economy, right? So as of now, since there is a lot of recession and a lot of other factors, right, that's why the stock prices are also, the market is also falling, and that's a global trend which is happening across. And some of those trends can be mathematically written, but a lot of those trends are driven by the sentiment of the whole market, right? So that's what it is. Now, before we go ahead, right, let's try to understand what is a time series data. Okay. Any idea what is a time series data? Time series is nothing but a collection of data which varies across time, right? It's nothing but collection of data points that varies across time. So for example, today, let's say it's 05/06/2022, let's say price of something, let's say price of maybe a car. Okay, let's say Maruti. Let's say it's 10 lakh, right? Yesterday the price was maybe 9.9 lakh, right? And probably week down later, maybe in May, the price was 8 lakhs, right? So anything that varies with time is a time series data, right? Any other examples of time series data? Stock price is one. Anything else that you can think of? Stock price and maybe car prices, house prices, temperatures. Even you can document something as IPL, right? So basically, when an IPL, there are 20 overs, right? So you see in a lot of those telecasts, you might have been seeing that in first over, there will be 10 runs, then it will be 11 runs, 12 runs. No, there is a graph like that. So this is what with time is nothing but number of overs. The number of runs in an over is varying. Isn't this also a time series data? This is a time series data, which along with runs, wicket also matters. So whenever with time, only a single variable is changing, that is called a univariate time series. Okay. And when with time, more than one thing are varying, that is called a bivariate time series. So for example, here it could be runs and wickets. This could be just price of, let's say, Apple. Other examples of time series data is nothing but like world population, stock prices, inflation numbers, sales data, right? So there's a lot that we can use, where we can use something like a time series. We have already talked about univariate time analysis, right? Where there's only a single time dependent variable. Then we have a multivariate or a bivariate, right? Bivariate when there are two, multi when there are more than two. Okay. So here with time, temperature, cloud, dew point, humidity, wind, a lot of these things are varying, right? So that's nothing but a multivariate time series analysis when more than one variable is dependent on time. Now we know about time series, but what all other components are there in a time series? Let's try to understand that. So when I say components, what I mean is that any time series, okay? So any kind of time series can be broken up into some constituent, right? So let's say I am tracking Apple prices. Let's actually go ahead and look at something like Apple prices. So if you see this particular kind of line, yeah, this is one day and maybe I can look at for a 1 year, right? So you see, this is nothing but a time series data. Now, can I break this particular series, right, into something that we can also use? So every time series data, let's say this, I'm just making some time series data, can be broken up into these four components. And when we do modeling, when we use machine learning, when we use algorithms for machine learning, What we are actually trying is we are trying to capture each of these components. If you can capture each of these components, you will be the master of, stock price prediction or any kind of time series prediction. So let's try to understand the first component of any time series, which is called trend. One thing before I move ahead, right? There's one website, right, which is called Papers with Code. Okay, this website will give you the latest and the best in machine learning, right? So for time series analysis, for example, okay, these are the topmost, best performing papers that you will see or best performing techniques. Okay. Today we'll be looking at some of the basic techniques, right? But if you want to, right, if you want to actually implement in a good way, right? If you want to actually look at best of the best in the market, right? So as of now, right, these are the two best implementations, right? In case you want to try and make your own AI driven product, right? Okay. So let me just quickly show you. So this is one library which you can use for stock price prediction, right? I mean, from intraday to different other things, right? It can do a lot. Okay. So for any task, this is stock price prediction for any task in this world that you want to apply machine learning on. Go to this website, right? Search for that particular task. It will give you the best that has been researched and benchmarked in the industry. Okay. So for example, if you want to do some other task, let's say you want to do speech recognition. Okay. So go to this particular task and you will get the best model that is there. So probably this is one of the best model that is there. Okay. So this is very helpful website, right? Today we'll be covering some of the basic models. Obviously, we have just 2 hours with us, right? So you can capture only some part of it, right? But post the session, right? Any task that you can think of, go there. So some of those will have implementation methods. So if you see code, wherever there is code, here you have the code, right? For these two, for example, I don't have a code. And these are the benchmark numbers. So this is 1.4, this is 1.5, right? Basically, in this particular speech recognition, the least number is the better number. So for different tasks, there will be a different benchmarking number. For some, you will have the code, some you will not have. And when we actually go through the implementation today, right, eventually we will be building something like this dashboard, right, where we have actually taken data of stock of Tata Global, right? So these are the actual values and these are my predicted values, right? So you can see it matches almost all the trends. And then we have actually done it for a couple of other stocks. So this whole dashboard that you see is built on top of Python, right? That you can actually build, for which I'll share the code also. Okay. So this is our eventual goal, right? We won't be factoring in a lot of factors. Today we'll be working on very simplified way, right? But you can take this and expand this to work on a lot of other things as well. Let's go back. So what is trend? So going up and down. So trend is nothing but long run increase or decrease over a period of time, right? So it's nothing but a long term increase or decrease over a period of time, right? So if I talk about Apple stocks, which we saw a couple, just now, if I see it in 5 years, what is an overall trend? What is the trend out there? Is it upwards or downwards? If I'm looking at 5 years, the overall trend is upwards, right? Maybe if I'm looking at 5 day, the overall trend is what? Downwards, isn't it? 5 day, yeah, or maybe even a month. Now it is recovering. It is a downward trend, yeah. So trend is one component, right, which helps us in analyzing the overall nature or overall, experience or overall direction where your stock is moving up, down, right? And then trend could also be looked at, whether it's linear or non-linear. For example, linear is nothing but a straight line. Many a times, right, which happens a lot in crypto market, right? That, I think Dogecoin and all. So suddenly the price was what? Less, and suddenly it spiked. And then it dropped also. We are not talking about the drop, but there is a sudden increase. So this is not a linear trend. This is what? A non-linear trend. So trends could be linear, could be non-linear, right? You can define it like it could be quadratic, it could be exponential, right? So few stocks you will find they have increased exponentially. So trend is one component where you get to know overall direction, right? So even if your stock value is this, what we try to say is overall it's upwards or it's downwards, right? So that is nothing but your trend component that we see. Moving on, there's next pattern, next component in a time series, which is called a seasonality component. So seasonality is nothing but, over a short term, what is the pattern, right? So instead of looking at 5 years, 6 years, right, we look at 6 months or a year, right? And we look at those patterns and see, okay, how did the stock performed in last 6 months or last 1 year? Yeah. Then there is the third component, which is called cyclicity, right? Which is in long term, how is your stock going up and down? So you look at from 10 years, 20 years peaks, right? Or from where the stock was listed in the stock market to now. Now, these are the three components: cyclicity, seasonality, and trend. If you can model, when I say model, if you can predict each of them, you can create your own prediction model. Then there is the fourth component, which is called nothing but noise. This is the place which impacts the most of all this. That's why there's no one technique till date or no software till date that can guarantee you that, okay, if that particular software predicts this stock will go here and it goes there. Yeah. Because of the COVID and so much market fluctuations like wars and all, right? The fundamental analysis has gone bit haywire because these are unexpected things in the market, right? If you talk about long term, it's still fine, but in short term, noise plays a key role. So we call this component as irregular component, right? Or we can call it residual component. We can call noise in the time series. So when we look at traditional methods of using stock market data or using time series data for prediction, right? The key there was to actually, that you have to make your time series stationary first. Since time series has so many components like trend, seasonality, cyclicity, and that noise, right? It is very difficult to incorporate each and every of those features, right, in order to predict. So what statisticians used to do was they'll convert the series into stationary series. Okay, basically it's nothing but a time series that does not change over time. Isn't it a contradicting thing? What I'm saying is that we have to make a time series that does not change over time. Okay, so what I mean here is that series itself can change over time, but the way it changes, right, does not change. Okay, let's see. Let's see these two kind of time series, right? So here, the first kind of time series is stationary, and then the last one is nothing but non-stationary. Okay, so when you work with traditional approaches, the way we approach any kind of time series problem is that you convert any kind of non-stationary time series to a stationary time series. Then you model it. Then you deploy your AI model out here. It will make some predictions, and then you again make it non-stationary, right? So basically, you will remove some noise here. This same noise that you removed here, you will add it here. Okay, that's how your traditional approaches have been, and that's why you won't find any traditional techniques to be working really good, and people using machine learning to predict, you know, stock market, and that's not happening, right? If it would have been that easy, everyone of us, at least the people who are working in machine learning would have created their bots which are doing, which are running for them and making money for them. So stationary time series is a time series which has a constant mean, a constant variance, right? So basically, what do you mean by constant mean and constant variance? So let's say this is the time series. Let's talk about mean. So mean is nothing but an average price. So if I have a time series like this, right? my mean value for every day was somewhere here, let's say. And suddenly there is a change in mean value, right? So these kind of time series are non-stationary. And what it means is there was something in the market that led to a dip suddenly. So you cannot use machine learning to model such kind of time series. Okay. Similarly, if you have a time series like this, where you see something as like an upward trend, right? This also you cannot model using machine learning, or you cannot model it using the traditional techniques of machine learning, right? Because the series is non-stationary as the mean is changing with time. Okay. Now you can say, if I cannot model such time series, I saw, okay, yeah, Apple was, it's like this. All of the time series are like this, isn't it? What's the use of using machine learning? What is the use? If I cannot model a time series like this, what is the use? Isn't it? Yes, mean value means basically in any given interval, it could be 1 day, 2 day, weekly, right? And how is that mean changing over time? The reason this happens is the underlying assumptions, right? Assumptions of this traditional, you know, methods, right? Which we'll discuss in a while. What are those traditional methods, right? These methods assume that your time series is stationary and only works when the time series are stationary, right? So what we do here is from non-stationary, we'll convert it to a stationary time series. Then you create AI model to handle trend, seasonality, cyclicity, right? And then you make predictions, and whatever noise you removed here, whatever trend or whatever component you removed here, you add it back, and then you have the prediction. Okay. So just remember this particular chart. That's how your machine learning in any time series work. So these are the conditions of stationarity, right? And we have some statistical tests that we do to check if any time series is stationary or not, right? We perform this on any data. Then we check if it is not stationary, we will actually make it stationary. So there are some methods to make a non-stationary time series stationary, like detrending. You remove all the trend, right? Then there is seasonality adjustment. You remove all the seasonality, or else you transform the data, right? That will help you make those time series non-stationary, and then you can use machine learning techniques on top of it. One of the techniques that we guys also use, and we didn't know that we were actually doing nothing but this. How many of you use something like a moving average when you are buying a stock? So maybe on a daily basis, right? On a daily basis, the stock is fluctuating a lot. But what you want to see is, if it is fluctuating like this, if you average it out, if you average maybe last 5 days average, and you see how does the last 5 day average is changing, isn't it more representative? I can see the overall trend and everything much more clear rather than looking at individual day-to-day values. So this is one of the ways to do, right? And enough of the theory, right? Let's jump to some hands-on session and get our hand dirty, right, in this. And whenever you guys want to break in between, let me know, right? I'll give an appropriate break in between. Any doubts on the theoretical parts, right? The thing that you have to take from this session is, what is time series data? What are the components of time series data? Trend, seasonality, right? And when you create a machine learning model, when you use AI to model that, right, then you cannot, the main thing that you have to focus on is building models for trend, seasonality, and cyclicity, right? Noise is something which will always be there, right? What our models assume is that if all the sentiments are fine, then your analysis work, right? And nowadays there are so much advanced techniques, right? Let me show you one of those techniques out here, where it was using Twitter data to do stock price prediction. I mean, I was looking at this and even I want to try this out, right? So this guy has created a Bitcoin value predictor. Okay. Bitcoin value predictor. And let me show you. Let me give you a walkthrough of the code in case you want to do, right? He has used Twitter API to get all the tweets about Bitcoin and currency, right? And then also on LinkedIn and everything. He scrapped everything, all the articles and everything. So basically undermining the whole sentiment, right, of the market. And then, right, and what he has done is he has curated the data from the markets, right, and then he has used that particular data to actually make predictions. So there is this tool called GitHub Desktop that you guys can, look at after the session, where you can download and run these codes on in your local, right? So it's like an easy tool to use GitHub. In case you haven't used GitHub Desktop, very much user friendly. You don't need any coding to do that, right? So what he has done is he has curated all the data, right, from different places, right, and he has divided that on one particular date, how much was negative, how much was neutral sentiment, how much was positive sentiment, and along with this, what was the price of that particular uh, Bitcoin, right? And then he used this particular data to check if the price is varying with the sentiments, and we can clearly see some trend. Can we see? Yeah, there is a clear trend. And then he has used this data to create a model, right? And then he was able to do some predictions, and these are nothing but predictions. If you see, so blue one is the actual price of the Bitcoin, and orange are the lines which he predicted, right? So in some point he was close enough, right, to do the predictions, right? And then he used you know neural networks to do the prediction. Okay, so with this simple analysis, simple code, you can actually run anyone's code, right, and do these kind of analysis. See, with a neural network model, how close I am to actual stock price. Always, if you want to go right, check these codes, try to replicate these codes, right? Due to less duration of the session, I cannot actually show you how to run each and everything, right? But you know quite useful things are there on this particular website if you want to look at what is the best in the industry. Okay, so today what we'll be doing is we will be working with two data sets. So one is an Infosys data sets, and the other one is a data set that I have for you know Tata, Tata Global, right? So the first step for any machine learning modeling is to collect this data. Okay, so I've collected two data set. One is was provided by a website called Kaggle, which has some data sets. The other way is you can actually look at Yahoo Finance, and Yahoo Finance has an API with which you can pull any stock data. So there is a API. You just do a pip install Python, Finance, and you just name the stock, and you will get all the data of that particular stock. Okay, so I have downloaded one of those data set here, right, which I'll be using. So first step for any machine learning models, any thing is collecting this particular data. All you have to do is you have to create a worker. Worker is nothing but you have to create an application, right, which keeps running in background, and you can define, let's say, that every 10 seconds it pulls the data from, let's say, Yahoo Finance. So it will keep on pulling the data from this, right, and serving it to you. But it's delay in market life. No, no, there's no delay. You can even do 1 second. You can do 100 milliseconds. How fast you need, right? Python is so much efficient that you can do anything. Okay. So for creating any machine learning model, okay, any machine learning model, may it be a time series model, may it be any kind of machine learning model, the first step is getting some historical data. Okay, so in case of stocks, the first thing that I did was collecting of this data. So I collected data of some stocks. This can be done via different APIs. APIs is nothing but different websites which track the stock prices. You can actually use that website data and bring it to your local and analyze on top of it. Yes, some APIs is fast, some are slow, right? So there are different APIs if you want to do live, right? So instead of actually looking at these websites, you can actually see how these websites are looking at the data. If you have to create an application which is for production, or for you have to create a real world application, you will have to fetch the data from the government backed indexes itself. And there are many companies like Rapid API, right? Yahoo Finance, Alpha Vantage, all these are one of the good websites to get stock market data easily. Okay, Yahoo Finance is one of them. But the thing is, Yahoo API has been depreciated couple of months, or I think it's been some time, right? So there is no future development, but it's still good enough. There is one more API called Alpha Vantage, right? Okay, for real time information on stocks, forex, cryptocurrencies, right? You can use that also. Okay, so there's a website called, so you can actually go here and connect to these APIs in your codes, right? And download the data from there. Obviously, I have to sign up here and to get access. Some of those APIs might be free, some of them are paid, right? So depending on that, you can collect the data. So once you do a sign up, right, you will be able to, you will get a key, right? And then you can use those keys and those credentials to access the data. Cool. So any project, any machine learning project, the first will be collection of the data. For stock, it could be via APIs. For anything else, it could be different. Okay. The next part is when you're creating a AI model, you have to divide your data into something called as train and test. So let's say I have historical data of stocks from maybe 2014 to 2000, let's say 18. Okay. So what I'll do here is I won't use all the data for training. When I say training, basically I want my model to learn. I want my model to learn at, okay, what are the trends, what is the seasonality and all those things. So I cannot use all the data. What I'll do is I'll use the data from 2014 to maybe 2017 as my training. And then I'll do prediction on 2018 data to see how good or bad I am doing, isn't it? If I don't know how my model is doing, I cannot just predict on future and put all my money there, right? Without even knowing how good or bad I am doing, isn't it? And this is nothing but your daily classes, right? Or your notes or your weekly test and everything, right? Everything else, everything is here, the way you are getting trained. And this is your final exam, right? If you are good in final exam, then you are a good, you may be doing good in jobs, you will get a good college, right? Although that's not necessary, but that's how we think, right? How do I evaluate if I have done good predictions, if I was doing good predictions in stock market? How do you evaluate? So let's say the stock price, I predicted stock price for tomorrow. So the market opens tomorrow, right? So it's 6 6. Tomorrow I predict the price of, let's say, what, let's talk about Netflix. So it's like 198, it was $198. Let's say I predict it as $199 tomorrow, and then maybe $200 day after, and maybe $190. I give next 5 days predictions. The closing price. So these were my predictions. And let's say next week in actual, this was, let's say, $200. This was $201. This was $220. And suddenly it fell, whatever. So how do I evaluate how good or bad I'm doing? How can I evaluate accuracy? Give me the exact formula. What do you think? How do I check accuracy? How do I check hypothesis? Don't go into so many terms of hypothesis, right? Basic. See, I said the price will be $199. It was $200. I was wrong by how much? Actual minus predicted is $1. Here I predicted 201, it is 201. Again, I am off by $1. This day I was off by $30. Here I am actually off by what? Minus $12. Here I'm off by -$5. This is the difference in my predictions. And how can you benchmark on this? How can I say that my predictions are good or bad? I cannot go to someone and say, okay, these are the numbers, mean squared error, or we can call it as root mean squared error, right? A lot of you know this by something called as standard deviation, right? It's actually similar to that. Okay, the way we calculate is, so let's say these are my actual values. These are my prediction values. And just for simplicity of maths, I'll um, take an example like this. So you do actual minus predicted. So it's -1, 1, 1, 1, right? The next step that you will do is you will square these values. So 1, 1, 1, 1. You will add up all these values. It's nothing but 4 divided by 4, right? Will be 1, right? So this, since this is squared, right? What we'll do is we'll do a square root of this. What is square root of 1? In this case, it's 1 only, right? And you'll get your root mean squared error. We call it as RMSE, right? So Python provides us a functionality where we can directly use this and evaluate how good or bad we are doing. So now we all know the basic. First, collection of data. Second, splitting it to train and test, right? Third, evaluating, right? So these are the three basic steps in any machine learning algorithm. Now you know. So let's look at this one data set, which is of stock price. We have taken stock price of 3 stocks or 3 indexes, right? I've used a very small data set because it takes some amount of time to run it, right? But you can use the same code and replace it with a bigger data set. Okay, I'll show you how. Cool. So first, what we are doing is we are importing some of the libraries that we use to run the code. Okay, so there are a couple of libraries that we use. So one of them is called NumPy. Then we use pandas. And then lastly, we used the same evaluation metric, mean squared error, which you see. By default, Python gives us mean squared error. We will do a square root of it to get root mean squared error. Okay, so let's quickly run this. So this is the data set that we have, right? This is the data set we have. So let me read this data, right? The data set has, if we see the actual data set, this is the data set. So I have dates. So it has data from 2015, right? This is the name of the stock, right? This is the previous closing, and at what price did it open? What price did it close? And what were the highs and the lowest, right? So we are interested in the closing price. So I've read this particular data set, right? And I have just used the column date and the closing price, right? And I've parsed the data like a time series data. So you tell the Python interpreter, Python code that it's a time series data. So you use this particular column as an index. And this is nothing but a data frame. So I can do df.shape. It will give me how much data points we have. So we have data for 248 days, which is close to an year. Yeah, because market is not working on weekends. Sorry, yeah, on weekends and on public holidays. The next thing that you can do is if you want to know stock price of any particular date. So for example, let's say I want to know for 2015 0101 or maybe 0107, let's say. So I can just write this name data frame, right, and check it out. Just give me a second. I'm missing some brackets. So you can see the close price of any particular date. I can check it for any other date, right? Any other month, and so on. Okay, I didn't have data for this particular day, so maybe it's not showing up. We can check the min and max value to see from where we have the data. So we have data from 2015 0101 to 2015 1231. So full year of 2015. Why I have used this particular year 2015? The reason being, so if you remember, how many of you have followed Infosys stock? In 2015, there was a split of that stock. Do you guys remember? For those who don't know. So on June 15, 2015, yeah. So there was a stock split of 1/2. That means each stock was split into two parts. So the reason we have used this particular data set is because this keeps on happening, right? And how do you incorporate such things in your data? Okay. So let's plot the data and see when did this happen. Okay. So Python provides us with a visualization library. And let me zoom the code for you guys, with which you can visualize the data. So what I've done is I've visualized the stock prices for that particular year. So if I model something like this dip in my prediction, will that be a good thing? If I add this sudden dip, right? This will be a bad thing or will be a good thing. So imagine today you had 100 stocks. Okay. The price of per stock today it was 100. Tomorrow you wake up it's 50, and market and everything is same. Isn't it a bad thing? So you have to adjust for such factors, right? So whenever you're doing training of machine learning models, it is very important to clean your data or adjust such things, right? So what we can either do is, right, when we are using this, we can use all this historical data and convert all this stock prices and divide it by half, or we can use this data and do a double of it, right? So we can do it either ways, right? So what we have done is, so there is a huge drop on 15/06/2015, right? This was the fifth split share in Infosys share price, right? And if I take the whole price, it might not give me the expected behavior, right? So I need to handle that particular thing. So the way we handle it is by dividing the stock price by 2. So if you see what I have done is all the stock price before 2015 6/12, I've divided it by 2. Can you guys see this particular code? And rest of the data I have kept as is. And I've created a new data set called stock price, which uses and combines the data set from before 2015 6/12 divided by 2 and after 2015 6/15, which is not divided by 2. Okay, I combine this and now I plot. So this is the plot we are seeing, and now it seems fine. There's no, now we are doing it on a same scale. Okay, so we call this particular step as scaling of our data. Okay, in time series data, this scaling could be about stock split up, or even it could be about COVID. If you are looking at sales data, let's say of a bag manufacturer, right, who just does offline selling, in March 2020 or in April 2020, the sales would have been zero, right? And it's not because of his fault. It was because of some external factor, right? So you will always have to factor in such things. Okay, awesome. See, coding wise, don't worry. Okay, and that's for everyone. Don't worry whether this is hard code, difficult code, easy code. Coding you will learn. Okay, focus on the concepts. Focus on how a machine learning model works. Focus on how you can actually go back and learn this and then apply it in your applications. Okay, so the takeaway should not be okay. How I'm using this in something else, right? The takeaway should be the concepts under these. Cool. Like I said, the intention of this session is not to cover up 10 concepts, but if I cover 5 concepts, you understand those concepts, right? And the concepts are related to machine learning rather than stock markets, right? Stock markets, a lot of you might be much better than me, right? Already. But the intention here is to understand time series data, to understand how you can use machine learning on top of it. So we have done adjustment now. Okay. The next thing is what we will do is I'll use the last 68 days as my test set and all the other data as my training set, right? So I'll use different methods, right, to create a model, to create a machine learning or an AI model, right? And I'll predict on the last 68 days of data, which I'll assume I haven't seen, right? So as to assert how good or bad I am doing on my data. Let's try first method, right? So what I have done is I have split the data into two parts. One is this training data, right? Let's call this as training. And this is nothing but your test data. Let's quickly run this. The first method that we are doing is, all I'm doing is whatever is the average of the previous values, I'll use that to predict the next value. Simple. I'll use maybe last 5 days average or last maybe whatever was the average value for the whole year and just do that prediction. That could be the most stupidest way of doing prediction, right? Or most easy way. So what we have done is I've taken this average values. I've taken all the training data set, right? And just taken an average value. So the average value, whatever it was the average value, I'm using that as my predictions, right? So let's do this. And if you see, these were the actual, the orange is the actual stock prices, and this green is what I have predicted. Obviously, it's going to be very bad, isn't it? I've done an average of all the values from here to here, right, for the whole year, and I predicted. So if you see, my mean square error is 3173, which is quite high. And if I have to calculate root mean square of error, so that will be somewhere around 56. So that means in most of the times, most of the days, I'm off by 56 rupees when I'm mentioning stock price, which is a lot, right? Which is a lot considering the stock price is around 900,000. So I'm off by almost 5% every day, right? It is not a clear indication. It's not a good model, obviously. Okay. So next technique, next simplest technique is something called as weighted mean. Different values have different weights. Exactly. So what we'll do is stock prices are more dependent on my last week, right? So rather than, I mean, it is more dependent on yesterday's price than a bit less dependent on day before and so on, right? So I cannot treat each value as equal. So what I do is something called as weighted mean, which is nothing but giving more advantage or more importance to the values, that occur just, close to time, right? So it's nothing but if let's say the stock price was 110 here, 120, 130, 140, 150. One way is I do an average, right? The other way is I took an average, right? But the other way is I give more advantage to the latest. This is more advantageous. This is bit less. This is even less. This is even less. This is even less in this. Yeah. I should give importances like this. So when you give importance like this, you give more weightage. So that is called nothing but as weighted mean. Let's go back to our code. So what we have done is we have calculated weighted mean. And when we are calculating weighted mean, right, what we have done is we have taken all the data, right? So divided it by 180, basically giving weightage to each one of them, right? To all the 180 data points, right? And then we have calculated the new weights, the new predictions. If you see the MSC is this, let me just change it a bit. np.sqrt is the function for calculating square root. So it's 59, right here it was 56. So it's still not doing so good. Let's see how the predictions are. Still not so good enough, right? So although I calculated, right, we did some weighted average, still it's off. Yeah. Okay. So now what we'll predict the value of stock on the day based on the values of stock price for the 80 days prior to it, rather than looking at all the days, because it's like you giving random weight. It's like we give not random. I'll say it's like we giving more weightage to recent items, right? Okay. With this, we also realize that there's so much of fluctuation. I should not look at price of January if I want to do predictions on maybe October, right? Isn't it? If I have to do daily prediction, I should not go so much back in past for at least things like which is a lot volatile, which is stock market. So for all the methods that we discuss now, what I'll do is we'll use data set from 80. So basically we'll consider last 100 days, right? Only. Okay. So 100 days for training the model and next 68 days for testing the model. That's how we have changed it a bit now. Okay. So I've defined again my train and test set based on this new analysis. So 100 will be done for training and only 68 for testing. So this is my X train. Okay. One more thing, what is X train, Y train, and X test, Y test? This is also one more convention that we use in in our machine learning models. So you have something called as predictor, and then you have something called as target. Okay. So all the dates in this particular data sets are nothing but your predictors, and target is what? Stock price. So generally all of this particular data is represented with the symbol X, and all the predictions that we want to do is represented with a small y. Okay, that's why you will see something like X train, X test, and Y train and Y test. So essentially every data set is divided into these four parts. This is used for training, this is used for testing, this is my predictor, this is my target. And this is common for any machine learning algorithm that you use, right? And such types of algorithm where you have a target is called supervised machine learning algorithms. Okay, because you know what to predict. Many times you don't know what to predict. Okay, let's say you want to find trends on Twitter. You don't know what you are looking for. All right. So that type of training or that types of machine learning is called unsupervised. What we are doing today is supervised machine learning algorithm because we know what we are trying to predict. So with this, let's move on. Okay. So we have created our X-train X-test. Okay. Now we have 100 rows in my training, right? For last 80 days. Similarly, I have X test, which is for 68 days and price for the stocks for that particular days. So the next technique that we use is something called as moving average. Okay. So what we are doing is rather than, looking at just the values, just the average value, I'll see how the average is moving. So every day the average is changing. So I'll do an average of last 2 days, last 3 days, and say that will be the average value of the stock. Okay, so let's do that. And as we did that, this is our MSC, and let's print our MSC also along with this. So now it has dropped to 53 from 56, 59. It has dropped to 53. So we know we are doing good. Let's plot it out. Now again, we try something called as weighted moving average, where we take moving average, but we also give weightage. Let's calculate this. This is my MSC, 3 dot square root. It has dropped to 42. I mean, such advanced 53 to 42. We started with 59. Think about it. Now let's draw. Cool. It's still better, right? Overall, it is capturing the trend. It is increasing here and then decreasing. Moving on from here. The next technique that we use is one of the machine learning algorithm. Till now, we were looking at statistical techniques that you guys can also do, right? The next technique that we use is something called as linear regression, right? So we again calculate this linear regression and create this particular model. So we create an instance of linear regression model from a library called sklearn in Python. We fit the model. Fit is nothing but the step is nothing but training the model. In all the other steps, we were just calculating something. This is training, where you are actually letting your machine learning models learn something. So it has dropped to 41 now, which is even, better now. So let's do that. Yeah, moving average is very lagging in live market. Exactly. That's why we also don't use. So see the difference from this particular line, you got to something like this. Isn't it a better representative? Isn't it following the market in a very good way? So from once we move from those statistical measures, moving average, weighted moving average, right? Why I'm telling you those, because you should know that you can do it without machine learning also. But once you move to a machine learning model like linear regression, yeah, now see the predictions, how close they are. Yeah. LR.fit is for training. Okay. Dot predict is for predicting. So this is training, this is doing inference. So if you see train, when I'm training, I'm passing both X train and Y train. When I'm predicting, I'm only passing the X or the predictors. Yeah, remember this predictors. I'm only passing this X, uh, this one in my prediction. During inference, I only pass this. During training, I pass both of this, right? Because this is hidden from the model. Although we have kept it, right? Since we have kept it, so I'm just evaluating on it. Okay. So we tried one more technique. The RMSE was higher, so obviously doesn't make sense. Okay. Then there is something called as Lasso Regression. Again, one of the versions of regression models and the machine learning algorithms, right? All these are linear models that we are using till now. And if you, let's quickly check RMSE for this. It's again 45, not so good. The next thing that we do is we use machine learning, subset of machine learning called deep learning, right? Where we'll use this. So now what we are doing is we are using neural network to do our analysis. This is one of the most advanced algorithm, right? Neural network is like mimicking human brain, right? For you to run this, you need a GPU, a graphic processing unit. So that's why I'm running it on cloud. Kaggle offers me cloud services where I'm running these. I've run this. Okay. Let's quickly see if it's better or worse. So it's not one-shot learning, right? You'll find that you'll have to do a lot to get something out of it. It will take some time to run. It's running. Because you're using graphic processing unit, it takes some time to run. And you can see this output in consoles also. So at the back end, all this is getting executed. Cool, we have it. and the RMC was quite high, not so good. Okay, so we try a couple of other models also. Okay, so one of the models that work really good is called nothing but Lstn, right? So what we have done is we have created a model called Lstm here, right? And I've used the data as is to do predictions, right? And if you see now, even with adding the data as is, I was able to do quite good predictions out here, right? Now you can improve on these models, right? You can keep on adding and improving these models by using more and more sophisticated techniques, adding more data, adding more variables. You can add you know, market variables. You can add Twitter sentiments, like I showed you, right? So you can use this as a base, and from there on, you can build on by adding more and more factors that are there in the market, right? Like Dev, you were saying you want to give more weightage to maybe last year. So that is what weighted linear regression did. Okay, which was not doing so good. So based on this, just keep on adding, keep on experimenting. And that's why it's a daunting job when you want to use AI, right, to create such things. It's not an easy job, right? So today we tried 7 different models to do a stock prediction, and the best we got was an RMSE of 40, 41, which is still good, but not great, right? Now let's see how you can deploy this. Okay. So what I've done is, let me show you, I've deployed it in my local. So when you are working for an organization or when you are working it for your own software, how you do that, right? So what I've done is, so this is my code file where I have used data, this is a bigger data set. I've taken some data from for data stocks, right? All right. I have used that and created a Lstm model, right? Using this particular model, I've trained this particular model and I've saved this particular model in a file called saved lstm model.h5. So this is nothing but your AI model. Okay. So like you have CSV in computers, you have AI models that you can save in memory. So I've saved this model. Okay. Now what I'll do is, this is the backend of my computer. I'll go and run this. So Python, and I'll run this particular file. So what it will do is it will run fire GPUs in my machines, right? And then it will train the whole model. And once the model is trained, right, I should have that particular H5 file saved somewhere in my system. Okay, so let it run and let's see if it is able to save it. So it has completed. So let's go to this particular location, and yes, you can see this particular file just saved on my laptop, saved lstm model.h5. If you try to open it, you won't be able to do. Okay, it's a .h5 file which only Python can read. Okay, so now what we do is I create an app file where I will read this data. I'll read this model. I do some predictions on, on my test set, right? And then I want to visualize this in an HTML format. So let me just close it down, put it down. Okay. So what I'm doing is I'm reading all the predictions. I'm plotting it out on an HTML file. This could be your software. This could be your mobile software, right? So based on different, I wanted to create a web app. So I've created a web app, right? Using a technology called Dash, right? Package called Dash, which I'm using to create HTML web apps, right? So first thing that I'm drawing is I'm plotting the actual data. Then I am plotting my predicted data, right? And then I have a different tab where I'm also plotting data from Facebook and other. I have data from Facebook and other clients also, which I'm plotting it out, right? And then I have for Tesla, Apple, I'm plotting all those things, right? Couple of things that we have done here. And finally, I'm running this app. Okay. So let's save it and let's run it out. Python stock app.py. So it will load the model. Okay. It has loaded the model. And if you see serving Flask app stock app on this particular URL, let's go to this particular URL. This is a local URL. You can host the same thing on your website. So whatever we did, we have done actually the same prediction. So this is one of the good model where we have added more data. And if you see, these are my predictions and these were actual values, how close they are, isn't it? And then I can actually zoom in, zoom out, all those things I have done. So you can do all such things, right? Once you add it and serve it as an app. Okay. This is a very basic app, very basic production app that we have created. Okay. So with this, I'll end today's session. Okay. Cool, guys. So thanks everyone for joining in. Have a great weekend ahead. All right. And hope you learned something new today. Thank you.
Yeah, thank you, sir. Thank you for joining this session, and thank you for all your expertise. It was a great session. Thank you, sir.
Thank you.